Hello.
Hi, Chase.
I will be right back. I'm going to grab a piece of paper to write on.
Okay. Do you have a list of the exercises you're supposed to do on these two chapters?
Yes, I should. I meant to send them with the questions this week.
Okay.
Here they are. This is 5.5. 5.5.
Yeah, you sent me 5.5 and 5.6 are the two chapters or sub-chapters that it looks like we're going to cover today.
So there in the chat, I go to meeting I put which questions you wanted.
Okay, so 47 is where we want to start?
Yeah. Unless, of course, you see anything in the previous questions that looks important to review.
Well, let's make sure you can do this one. Not that one. Well, yeah, let's make sure you can do that one also. How do I do that?
How do we do log of 2 to the 1/8?
Yeah, without a calculator. Log base 2 of 1/8.
So that involves the properties of logs where you can move around the bases and stuff. Right?
No, not really.
Exponent.
No. Let's go ahead and make that equal to x, because that's what they're asking for, is what this is equal to. And now, once we have it in a logarithmic equation, we can turn that into an exponential equation.
Yeah.
What is the exponential representation of that?
Is that 2 to the 1/8?
It's 2 to the x equals 1/8.
Oh, 2 to the x equals.
The way I always remember it is it's the number on the far left raised to the power of the number on the far right equals the number in the middle.
Okay.
What is x? What would x need to be to make 2 to the x equal 1/8?
-3.
Good. Okay, so that's how you do that. The second one is a little more complicated. Let's look at it briefly. I'm going to let that equal to x, so now solve that.
So then we have 27 to the x equals 9. And then we need... It's not that.
Yeah, this isn't quite as easy to solve once we have it in exponential form. However, this is very similar to problems you will get on the ACT and SAT. The solution to this problem is finding a common exponential base. Well, what's the common exponential base between those two numbers?
2? Or
3.
3. Sorry, yeah.
By that, and by common exponential base, I mean I can write 27 as 3 cubed.
And
I can write 9 as 3 squared. Now, using my rules of exponents, I have 3 to the 3x equals 3 to the 2. And now, because I have same base, different exponents, I can equate the exponents. 3x equal 2. So x equal 2/3. Put any other numbers, make that 8 or make that 26, and the only way to solve it would be with a calculator. The only reason we can solve these problems without a calculator is because they have a common exponential base. Let me give you another one just to make sure you understand.
So they have the common base of 2.
Okay.
So we would have on the left this 2 times 2 is 4 times 2. We'd have a 2 to the 4 times x plus 3.
Well, let's write it like that, first of all.
Okay.
When you rewrite these, always put parentheses around them.
And then that's 2 to the 3rd and 3x.
Because only after you have parentheses around them can you then apply the rules of exponents. In other words, that is a different answer than this. Not the same thing at all. Those parentheses change everything. Okay, so now what can I say about the left side?
So then you multiply that 4 through, so you get 4x plus 12, right?
Uh-huh.
And then on the right side you have 9x.
And now we can equate that to that and solve. Okay? So look for those kind of problems when you take the SAT, because there are a couple of them. They don't require logarithms, only because they have a common exponential base. That's the only reason we were able to do that without a calculator. All right, now let's go ahead and start where you're supposed to start, on 47. I haven't really looked at any of the ones in between. Okay. What is g prime of t?
47.
Uh-huh. Oh, is my 47 the same as your 47?
It is. I was just saying it aloud so I could check myself.
Yeah, I didn't even think about that for a moment.
Taking the derivative of t squared.
Okay.
2t. So the first one turns into, so we have to do the product rule first, right?
Correct.
So we get 2t, 2 to the t, plus t squared, and then the derivative of 2 to the t. Is that the natural log of 2 times 2 to the t?
Yes. In other words, and that's the best way to remember it. The derivative of e to the x is always e to the x. Okay? But the derivative of anything else to the x, say 3 to the x, is 3 to the x times natural log of 3. That's the key thing to memorize when you're taking derivatives of something other than natural log, which, I'll be honest with you, doesn't happen very much. Once you get into calculus, you kind of forget about all logs other than natural log. Okay, 49. Let's see, was that a final answer? Let's just check what they're... I could see maybe that we would want to factor something out here. We could actually factor out a 2t times t, leaving behind 2 plus natural log of 2t. So I could see their answer in the book being that. Let me look real quick.
You gotta remember the factors.
Wow. What the heck did I do?
I could look to see if that's what my teacher got for that question.
Well, their answer in the book is completely different, but I think I understand it. Yeah. First of all, it's a mistake to write it like that. See how I wrote natural log of 2 times t? And the reason that's a mistake because it makes it look like it's the natural log of 2t. So let's write it properly. Let me put the t in front. Now you can't make a mistake as to what the argument of the natural log is.
Yeah.
Let's go back to this step right here before I factored anything out. Wow. Quite certain I did this properly, but here's their answer. You know, are you sure that your 47 is the same as my 47? Oh yeah, I took the 47 from your document, and I'm looking up answers from my book. And I'm not sure that 47 in my book is the same. Let me see. No, it isn't the same at all. So you're going to have to look up answers.
So,
What do they give as the answer for 47?
what we had when we pulled out the 2t to the t, or 2 to the t times t.
Yeah, we had this.
That's what they gave.
Okay. Plus natural log of 2, well actually t times natural log of 2. I pulled out the 2 to the t also, yeah. Let's see, I pulled out t 2 to the t, right? Which left 2 plus t natural log of 2. Yeah, this should be what they give right here.
That is what they gave.
Okay. And 49. H as a function of theta equals 2 to the minus theta cosine of pi theta. So H prime of theta is what?
So, again, we have to do a product rule here, correct?
Product rule with one of the pieces of the product being an exponential function.
So then, first 2 to the negative theta times sine pi theta negative pi.
Yeah. Put the negative sign there. Put sine pi theta times pi. That's the first part, right? In other words, that's this times the derivative of this.
This and the infinite.
So now let's write cosine of pi theta. And now we need the derivative of that.
And then that would just be natural log of 2 and then 2 to the negative theta, right?
Times negative 1. In other words, you still have to take the derivative of that inside. In other words, if I had 2 to the theta, and I said, what's the derivative of that? That would be natural log of 2 to the, natural log of 2 times 2 to the theta. But when I have 2 to the minus theta, it's the natural log of 2 times 2 to the minus theta times the derivative of the inside, which is minus 1. In other words, you have to still apply the chain rule.
Got it.
Now, can we do anything with that? Let's see. I guess we can factor out a 2 to the minus theta. In fact, I can factor out a minus 2 to the minus theta, leaving behind a pi sine pi theta plus a natural log of 2. No, it's odd. That's a number, so I keep wanting to put it as the coefficient. But the problem is when you put it as the coefficient, it can be misread real easily. The better way to not have it misread is to put this first. I believe the bottom is the same as the upper row. Notice I had to change that to a plus since I factored out a minus 2.
Yeah, that makes...
Okay, you want to check it in the book?
Let me look.
49?
Yeah, she has the same thing. She just wrote it in a different order.
Okay. 53.
For some reason she wrote Ellen 2 times off.
Well, there's really lots of ways to write these, and I'm not sure that one is necessarily more correct than another.
I just find it odd that she did the Ellen, the natural log of 2 first. Cosine pi theta plus pi sine pi theta. I just find it odd that she put the natural log in there first. So
well, that was my inclination to do, was to put it first, because that's just a number, and usually you put the coefficients first. The only reason I don't like doing that is because it's kind of hard to tell what the argument of the log function is when you do that.
Yeah.
It's like this. Is that the log of 22 to the minus theta? Or is that the log of 2 times 2 to the minus theta? There's no misunderstanding if I put the 2 to the minus theta first. So I suppose we really probably should use parentheses in a situation like that. All right. H of t equals log base 5 of 4 minus t squared.
And then, so, see, what would I do first?
Okay, let's look at what the derivative of the log base a of u is, dx. Well, that is 1 over u times natural log of a times u prime.
So, would it be first step then be to pull that to the, since I'm using the properties of logs and all, make it 2 log 5 of 4 minus t?
I was just sitting there thinking that that's what I would do. Yeah, I think that actually makes the whole thing a little easier. It eliminates one element of the chain law. We were going to have to apply the chain rule twice, but now we should only have to apply it once.
And then, so that's 2.
1 over
negative, yeah, 1 over, and then
4
ln
minus t
a
times natural log of 5
yeah,
times u prime. What is u prime?
negative 1.
So our answer should be negative 2 over natural log 5 times 4 minus t. And I guess that is the more conventional way of writing it.
But this one she actually wrote it the other way with the ln at the last part.
Did she really? Amazing. Because every time you look in the formulas, it always gives this as the general formula. In other words, it puts natural log of a first.
Yeah, what she did is when she multiplied the 2, she originally had the natural log first, but when she multiplied the 2 through, she switched where the 4t and the natural log are, writing the natural log last.
Okay.
I don't know why.
Okay. Let's see, that was 53, 57.
Log base 2 of x squared divided by x minus 1. So then, for this, would step 1 be using the properties of logs to break it into log base 2 of x squared minus log base 2 of x minus 1?
Yeah, that would actually make it easier, because if we were to do it straight away, we could certainly do it, but then we're going to have to take the derivative of the inside, and meaning applying the quotient rule, which gets very complicated. So I like your plan. Let's make it the log base 2 of x minus the log base 2 of x minus 1, right?
Yeah.
Okay, now we can differentiate that pretty easily and differentiate that pretty easily.
Yeah, so that's just, so over the first term turns into 2 over natural log of 2 times x. Minus 1 over...
Boy, that is, I guess the parentheses really need to be placed around the natural log of 2, like that. And that way it can't be misinterpreted.
And then minus 1 over the natural log of 2 x minus times x minus 1.
Times what?
X.
What's the derivative of the inside?
Oh, 1.
Oh, you're right. Sorry. My mistake. I was thinking it was minus 1. Yeah. So that's a acceptable answer. Is that what she has? Is that what she has? Because I could see all kinds of other possible answers here if she tried to put it back together.
She did put it back together. And when she put it back together, she got x minus 2 over ln 2x times, or ln of natural log of 2 times x times x minus 1.
Which is all she's doing is adding or subtracting those two fractions by finding a common denominator, which is clearly natural log of 2x times x minus 1, which makes this side over here x minus 1, makes this side over here x, and that's how she got that.
Back together.
Yeah. Alright. Interesting that she did put them back together again. Because I'm not sure what the rules are for simplification in that situation. What is simplified? Find an equation of the tangent line to the graph of the function at the given point.
So we have to take the derivative and then plug in the derivative and then plug in the...
Well, we have to take the derivative, and the derivative is the slope. So that's our first task. And then when we figure out, we could use point slope or whatever equation you want and plug in those points, and we'll have the equation of the tangent line. In other words, the key for the equation of the tangent line is to figure out slope. The key to slope is to figure out first derivative. So y prime is what?
So that's 2 to the negative x natural log of 2, and then the whole thing times negative 1, so that's the derivative inside.
Mm-hmm.
Right?
Right, like that.
Yeah.
Okay. Now, that's our slope. And they want it at what point? Well,
negative 1.
Negative 1 for the moment. So
Yeah.
we're going to plug in negative 1 here. So y prime of negative 1, so to speak, whether they like this notation or not, I like it, is minus natural log of 2 all over 2 to the x, 2. Hold it. Excuse me, it's minus natural log of 2 times 2, isn't it?
Yeah.
So that's the answer. No, excuse me, that is the slope. So we're going to call that the slope. We could even say natural log of 1/2 times 2. In other words, I could say that that is 2 times natural log of 2 to the minus 1, which is that. So that's the slope at the point x equal minus 1. So how do we come up with the equation of the line?
We then put...
You can do it
like the equation in y equals mx plus b, plugging in those 2 points and that for the slope, and we solve for b.
There you go. That works fine. Maybe isn't the most direct, but it works just fine. So I've got 2 equals 2 natural log of 1/2 times minus 1 plus b. Right?
Yeah. Then we solve that.
Hold on. There's a big problem. What is it? Oh, no. Yeah, no, we're fine. I'm not taking the natural log of a negative number. I should have put parentheses around that. Okay? Because otherwise, I'm violating the domain. I cannot take the natural log of a negative number. Something was wrong. But
Yeah.
b is equal to 2 plus 2 natural log of 1/2. Which means the equation of the line is y equals the slope, which was 2 natural log of 1/2 times x,
Plus b value.
as strange as that answer is, if you're not allowed to use a calculator, that's what you got to come up with. You could probably factor out a 2, and that's all. I don't know. Are we supposed to be able to use calculators on this part?
Much.
I don't know if we are or not, but I hope not, because this is a prettier answer than a calculator answer.
Yeah.
This is precise. A calculator answer would be imprecise. It would be rounded. Now, like I said, you might factor out some things here. Looks very much like I could factor out a 2 natural log of 1/2, leaving behind x plus 1 plus 1, so x plus 2. Yeah, now that definitely looks more simplified than anything else. So I would say that's what her answer would look like.
She got, this is 63, right? Yeah. She got y equals negative 2x natural log of 2 plus 2 minus 2 natural log of 2.
Say it again? Minus 2x.
Natural log of 2 plus 2 minus 2 natural log of x. Oh, natural log of 2, sorry, not natural log of x.
Notice that that is almost identical to that. Let's erase what I simplified it to. Log of 1/2 is the same as minus natural log of 2. So this whole thing right here is the same as that. Notice that the natural log of 2 to the minus 1 equals minus natural log of 2. And natural log of 2 to the minus 1 is the same as natural log of 1/2. So the natural log of 1/2 is the same as minus natural log of 2. So all she did was take my natural log of 1/2 and switch it to a minus natural log of 2. And she did the same thing over here.
Yeah.
I guess this is the more proper convention rather than having fractions in your arguments. I didn't know that, but I can kind of get it, why it's that way.
Yeah. Okay, well that makes sense, bro.
Yeah.
Okay.
And 65. We're supposed to do all odds here, huh?
Yeah.
All right. We may or may not want to spend all of our time doing these. Let's see if you know how to do them first.
Yeah.
If you know how to do them, we'll skip the ones in this section. So
first the derivative, which is just 1 over x natural log of 3.
okay.
And then we have to plug in 27.
Now, are you familiar with the point slope format?
I've used it before, but I've had issues memorizing it and using it properly.
Okay. Because it's probably a little more direct way to come up with the equation of the line. You don't have to solve for b.
Yeah.
And it's not hard to remember. It's y minus y1 equals the slope times x minus x1. And of course, notice that if we divide both sides by x minus x1, that's the definition of slope. Rise over run. So it's really not hard to memorize. And let's try it here just to see whether it makes it simpler. notice we're not going to have to solve for b. We've solved for the slope, and we have our 2 points. So we can come up with the equation in one step. So what is it?
So we have y minus 3 equals 1 over our slope there, and then we have x minus 27.
There you go. And in some circles, that would be the final answer. Now, your teacher may add 3 to both sides or distribute this. I don't know. But it's worth knowing how to use point slope. Just because, as you can see, it was 1 step instead of 2. Now, some may argue that this is not in an adequate format, but I would say that it is. In other words, this is the equation of that tangent line.
Yeah, that's a whole lot easier. I just had issues.
Now, you could, if they wanted in y equal mxb format, then you have to distribute that. You have to add 3 to both sides.
Yeah.
Then you would have it in y equal mx plus b format. But they didn't say that here. They just said the equation of the line. And when you use point slope format, especially when you have a slope and 1 point, both coordinates of 1 point, then it actually is significantly easier.
I don't know. I was taught it years ago and I just never quite fully started using it.
No, most people tend to favor the y equal mx plus b.
I think it's purely because I was taught it first.
Yeah. All right. Let's look at 67. Notice that we don't have any rules for x to the x. We don't know how to take the derivative of x to the x. If this lower x, if this x right here was a number, then we could do it using what we've just learned. But when you have x on the equation line and x in the exponential, there's no rules that work for differentiation other than taking the log first. And that's what they tell us to do here anyway. Use logarithmic differentiation. Well, what they mean is take the log of both sides first. The advantage of that is now you get to bring that exponent that we didn't know how to deal with onto the equation line. Now, implicitly differentiate this.
So then we get 1 over y dy dx equals, that's a product rule, isn't it?
Yes.
So then we have 2 over x times 1 over x plus the natural log of x times negative 2x squared over x squared.
Yeah, let's first of all write this as 2x to the minus 1. Now it's not as easy to make a mistake. Okay, so it's minus 2 x to the minus 2. Okay. So what is that? That is now, so what is y prime?
Y prime is then, we have to clear away the
Now, they didn't usually, well, I don't know whether, I'm guessing her answer is going to be entirely a function of x. It wouldn't have to be. In other words, I have to multiply both sides by y, right?
Yeah.
All right. So here's what
she has a y in her answer.
Okay, so she didn't resubstitute. I have a choice. I can go back and substitute x to the 2 over x for y, because that's what it is. That's what y is. But I can leave a y in the answer. A lot of times when you implicitly differentiate, you get an answer that has x and y in it. Let's see, what else do we have here? We have plus natural log of x. This is a minus. A 2 natural log of x all over x squared. Is that her answer? You can probably factor out a 2 over x squared, actually.
She does factor.
Yeah, I wish I knew the rules on that. Are you always supposed to factor out stuff that you can factor out? Not honestly sure. That certainly, if I haven't made a mistake, could be one answer. Now, a better answer is if you do go back and substitute x to the 2, well, or is it? It's not really a better answer. Well, what does she have?
She has that.
Okay, she has this?
Yeah.
All right. I was going to say it might be a better answer to substitute for y, because then we could simplify a lot of this. But then I looked and I saw that that was x to the 2 over x. That doesn't simplify. So I'm not sure what the point of going back and resubstituting would be. 69.
So then it wants us to take the natural log of each side again. So we can pull that x plus 1 down in front. And then take the implicit differentiation. So we have 1 over y, 1 over y prime thing equals x plus 1 times 1 over x minus 2. Which, yeah, we can write it like that. And then since the inside is 1, we can make that. And then we have plus the natural log of x minus 2, and then since the derivative of the other one is 1, yeah.
So now y prime is all of this times y. And is it going to help in this case to substitute that for y? Well, it actually would help with this term right here. Notice that if I go back and substitute x minus 2 to the x plus 1 for y, and I multiply all of that, I can actually distribute it to the first term and simplify it.
Yeah.
Because I'd have x minus 2 to the x plus 1 divided by x minus 2 to the 1. That's x minus 2 to the x. But then I would have to have it as the coefficient of this all over here. Or would I? In other words, I have a common base. Ooh, I've never seen that. What is x minus 2 times the natural log of x minus 2? I don't know. I'm guessing this probably is her answer, only with a y instead of this.
Oh no, she has it written exactly as you do right now.
Very interesting. The last problem she left with a y. This problem she substituted because she probably saw the same thing I saw and then realized that it doesn't really simplify by distributing it.
Yeah.
I could simplify this term times this, but then when I multiply this by this over here, it's just not really any simpler. Okay?
Rules on simplifying seem odd.
Yeah, I'm not positive that there are rules, to be honest, or I haven't learned them. It's been a while. I probably knew them when I was in college, but since I've relearned all this stuff since then, I don't get anybody around that tells me. The only way I find out the rules are seeing what your teacher answers and see if I can derive the rule from their answers. But your teacher's kind of all over the board like I am. Maybe there aren't any standard rules. Okay, so I'm going to evaluate this at e minus 1. Now, the one thing that I know is if I have 2 points to evaluate it, then I certainly don't mind having y prime as a function of x and y, right?
Yeah.
Because I have both x and y.
Why?
So it'll be super easy to plug these in once I have y prime, even if it is a function of both x and y. There would be no advantage to take extra work to make it a function of x alone.
So then, does it want us to take the natural log of both sides here again?
Yep, only because we have the variable and the exponent. There's no other way to handle that.
Yeah. And then we have to take the derivative.
This might look strange, but it's not really.
Oh yeah. No, that looks fine. You just...
I mean, you can have double logs. I've seen it plenty of times. So that's y prime.
Yeah.
And since the only thing we need is the slope, there's no point in going back and resubstituting for y, because I can get the slope by substituting 1 for y and e for x. So let's do it. Y prime, the slope, is equal to cosine of e. You don't see that very often. When's the last time you saw that? I've never seen it.
I've never seen it.
It makes me think I made a mistake, but I don't think we did. Natural log of e, which is 1, right?
Yeah.
And the natural log of 1 is 0. So there's the slope. So what's my equation of the line?
Y equals B, which would be... Is that just Y equals 0 for this?
It's y equal mx plus b.
Yeah.
We're going to plug in e for x, which doesn't matter, 1 for y, that's 0, so b equals 1.
1.
So the equation is y equal 1.
That's
a horizontal line. Find the equation of the tangent line to the graph, the function at the given point. Well, that's certainly odd, but I think that's the answer. Y equal 1. I don't know. Do you have it?
let me go look real quick.
She certainly won't have anything other than that.
She got something different. She got y equals cosine of e over e plus 1 minus cosine of e.
Something like that?
Yeah, she got.
Let's go back and do it again. Did I make a mistake on it? You started. This was 73, right?
Yes.
Started with natural log of x raised to the cosine of x. Okay, we take the natural log of both sides. And then we have the natural log of y equals cosine of x times natural log of x. And then we have y prime over y. So we have y prime equals y times that whole thing. So now if we plug in for e and 1 for x and y on the right hand side, we have 1 times cosine of e times the natural log of the natural log of e. Right?
That's what I get.
Natural log of e is 1.
1. And then we get
Natural
0.
log of 1 is 0.
And everything cancels.
So we get y prime equals 0.
That's what I get.
Did I not use the product rule? Just a second. Yeah, there's no product rule needed. In other words, you solve for... hold on a moment. Hold on. Let's back up a step here. I did this awfully quick. I think I made it. Oop, I shouldn't have erased her answer. Okay. So I took the natural log of both sides.
Yeah?
Okay. Now I'm going to differentiate both sides. Okay, I didn't use the product rule and I'm supposed to. I jumped straight away. I differentiated the left side and I didn't do anything to the right side. Okay, so that's where I went wrong. So we need to use the product rule. So we got the cosine of x times the derivative of that.
Which would be 1 over ln.
Like that.
Yeah.
Right?
Yeah. Yeah.
And then I can take that x and put it in the denominator like that. Plus the natural log of x times minus sine x. There, that's better. I thought I did that differentiation awfully quick. I don't know what I was thinking. Now y prime is equal to y times this whole thing. So now I can come up with the slope. So y prime evaluated at e comma 1 is equal to 1 times cosine of E over E times 1 plus natural log of E, which is 1, times whatever is, it doesn't matter what is that because that's all going to 0. So the slope of my line is cosine E over E. That equals to the slope at that point in time. So if I'm using my point slope formula, what do I have?
We have y minus 1 equals a slope there times x minus e.
So that should be the answer. If I wanted in y, and I could do a lot of simplification there. Let's do some. Was her answer y equals?
Yeah, her answer was y equals.
Okay, so we have cosine. If I distribute this x, I get x cosine of E over E. And if I distribute the E, I get minus E cosine of E. No, I just get cosine of E. In other words, that E cancels out with that E. Plus 1. Is that what she has?
Yes.
Okay.
Well, yeah, that's what she has.
Okay. Because there's other things you could do. You could factor out a cosine E. But, yeah, clearly the first time I did it, I forgot to take the derivative of the right side. After I had taken the logarithms of both sides, you got to differentiate both sides. I had only differentiated the left.
Yeah.
All right.
Yeah, that makes sense.
Yeah. It's 3 o'clock. What number did we just do?
That was 73.
73. Okay. So we got through all the derivatives.
Yeah.
So the only thing we didn't cover is the integrals, and it looks like there's quite a few of those, but hopefully you can do those. Just know that when you finish integrating and you take the derivative, you better have 3 to the x power.
Yeah.
So.
Thank you.
All right, Chase. Good luck. I'll talk to you next Saturday.
Talk to you next Saturday.
All right. Bye-bye.